All right. So I want to talk about networking and threading and putting those together today. Um, and then I want to talk about some of the issues of threading, um, some of the difficulties we can get into and how we deal with those. And this is partially related to Java. It's partially more general. It's any time that you're doing threaded programming. It's a subject you'll get a lot more of in future courses, but this is a appropriate place to introduce some of these concepts because we're talking about threads. Thursday, I'm probably going to do an open lab. Okay, PA5 is due on Friday. Have not had a lot of people coming to office hours so far. Um, so either people have nailed this, or they're confused beyond asking questions, or they haven't really dug into it deeply enough to have questions yet. So Thursday I'll do open lab hours, no lecture, and then we'll go on. We'll talk about some other networking aspects on Friday next week. We'll dig into a few trailing topics. I might do a talk on Android development because Android development is very similar to, I mean, it's Java, right? And working with GUIs and stuff is very similar to what we've been doing in Swing. So I might do that one day next week. We'll leave a day for review and prep for the final exam and so on. So we're kind of in the home stretch here, but we still have material I want to get through on threads in particular, and a little bit on sockets. So, any questions before we hop into all of that? Besides, why my screen is always tilted. All right. Well, let's go Eclipse. And I don't know where I left off my server class, so let's hop in and see what we wrote. So the server was listening for connections on port 1111. Accepting a connection, created a scanner, and then just printed out what it received. So it was kind of the receive side on the server. What I want to look at today is sort of a more general question. Suppose we want to do the following. Suppose we want to make a client-server pair where we have two-way communication, right? So right now the client can read from standard in, and it can send it to the server, and the server can read from the client and print to standard out. And this is sitting in a loop, and this is sitting in a loop. So if we run the server code and we fire up telnet, right? Telnet is the client side. It's reading from standard in, sending to the socket, and the server side is reading from the socket and printing to standard out. And this will just run forever until we close out the connection. All right. Now, if we wanted to make a chat program where the client can send messages to the server, but the server can also send messages to the client, at some level, that's not too hard. Right. All we would need to do is, before we loop back up to the top, we could say read from standard in and send to the client. And when we send from the client, we would say read from server, send to standard out. and then go back up to the top. Alright, so theoretically that's straightforward. There's a problem with this approach though. And this has to do with the concept of a blocking read. So let's go ahead and do this and see what happens. So we're going to read a line from the client. We're going to print it out, and then let's read from standard in. So so let me make a scanner object. I can do it inside here. This is sloppy week here in 223. So scanner standard in equals new scanner system.in. So this is for reading from our keyboard. So my buffer is going to be standard in dot next line. And then I'm going to send that out to the socket. And so I'm going to need a print writer on my socket. And I'll import that. And I'll construct my print writer here. From the socket.getOutputStream. And so here I'm going to read a line from standard in, right? This is the user's input, and I'm just going to say print writer, print line, buffer. We'll send to the client, and we'll flush as usual to force it to come out immediately. Alright, so if I run this and I start my telnet session, I can say hello there, and I receive the message hello there, and from here I can say you made a typo, and over here on my client window it says you made a typo, and I can say you're a typo, and it comes out over here, right? So we have two-way communication going on, but the problem is that right now this program, the server program, is waiting for the client to send something, right? And so, hey, I want to say something. Are you there? Hello? Right? Nothing's happening, right? Why? Because my server program is sitting right here in this loop which says read the next line from the socket, right? And there's nothing in there until the person on the client side says, you know, send this to the server. And so that goes out to the server, it takes us out of there. We read that first line from standard in, hey, I want to say something. We send it out to the socket, and now we're back up here and we're waiting for another line from the socket, right? In other words, the problem is that these processes are required to move in lockstep, right? This has to send to the server, we get from standard in, and then we send that to the client. And then the client reads from standard in and sends that to the server. And if the server wants to send 2 or 3 or 4 messages, it has to wait until the client has sent that many messages first. Okay? And there's ways you can get around this, but they're not ideal. Okay? And so what is a blocking read? A blocking read is basically saying when we're in our server code and we're saying let's read from the socket, we will not return from this call, where are we, right down here, where we say get the next line from the socket. We won't return from that call until there's something available to read, right? down here where we read from standard in, where we call next line on this scanner that we opened on system.in, we will not return from that call until the user types something in and hits the enter key. Okay, they're blocking reads, meaning that once you go into this method, you don't come out until it completes. Now, what we could do is, instead of just saying read from the client, we could try to say, is there anything available to read from the client? And if there is, we'll read it and print it. If there's not, we'll go down and we'll say, is there anything available from standard in? And if there is, we'll read it and send it. If not, we'll come back up here. And so we can do a non-blocking read, which basically says, you know, give me the input from the user if it's available, but if it's not, come back right away and tell me there was nothing available. Okay, that will work, but it's going to mean that we're in a loop that is constantly doing stuff. Okay, this is going to be CPU intensive. Right now, when we say read from the client, right, we're sitting in here. If we were to do a PS, and I don't know if I can find it in here. But one of these is probably this one, is the Java program that I'm running right now. Yeah, server main, right? If you break this information down, this S here, this is sleeping. Okay. This job is not using up CPU time. It's not going to show up in the list of things that are consuming CPU resources. Okay, this Java code down here, that's a totally different program. So this is efficient, right? It's waiting for the operating system, the JVM, to poke it and say, hey, we've got characters available for you, and then this process will read those characters, return them as a string, and this code will continue. Okay, if we do something with a non-blocking read, we're going to be CPU bound. So the better way to deal with this is to use a thread. All right, and this is a classic application of threaded programming. This is what I used to do for PA5 in this class. Was have people make a chat program using threads. So the way we break this into threads is do something like this. Have one thread which just reads from the client and prints to standard out. Have a second thread that reads from standard in and sends to the client. And since they're two separate processes, they're both doing their own thing independently. And if I get 5 lines from standard in, each of those will get sent to the client, even if I haven't gotten anything from the client to print to standard out. So this might be sitting right here, non-blocking, or blocking, waiting for input from the socket, while this thing is, you know, reading input, seeing the enter key, sending it to the client, and just having a heyday with that. So let's set this up. Okay, let's break one of these off into a separate thread. And some people have asked me, you know, how many threads do we need for NetDots? You can get away with just creating one additional thread. Okay, and that's what we're going to do in here. But you know, we could make a pair of threads, one for doing this, one for doing that, and then we have the main program. For a total of 3 threads, and if we had swing stuff in the background, we'd have 4 threads. The more threads, the better, right? Maybe. But let's make it simple. Let's just keep this in the main program, and let's put this in a new thread. Okay, and we'll see how we can break this lockstep. So let's make a new class. And let me change the names of some of these things. Because there's always a confusion of if you just have, you know, like send and receive, who are you sending to? Are you sending to the display, or are you sending to the socket? Are you receiving from standard in, or are you receiving from the client? or is it all done from the point of view of one user, and the server is receiving or sending to that other socket and so on. So let me put some more reasonable names in here. So I'll just leave socket as sock, but instead of using SC, let me call this from client. Let me call it from socket, because if you want to use this code for net dots, right, we want the same code for the client and the server. So so I'm going to construct my from socket by using the socket's input stream, and then while from socket has next line, I'll read from socket. And my print writer, let me call this to socket. All right, and then let me move my scanner up here. And let me call my scanner for reading from the keyboard from keyboard. All right, so I'm going to leave this tight loop up here that reads from the socket and prints to standard out. I'm going to leave that in here. So this reads from the socket. It's going to print out to standard out, and we'll just end our loop right there. Okay, and let me completely get rid of this stuff. All right, so before I begin this, I'm going to make a new thread. So let me start a thread class. And what should we call this thread? Well, this thread is really reading from standard in and sending to the client. Okay, so so let me call this this is going from the keyboard to the socket. I'm going to say this extends thread. And I'm going to make the run method which will run in a separate process. And so what do we want to do here? We want to read from standard in. Okay, so so I'm presumably going to have a scanner called from keyboard. So we'll read that in from the keyboard, and then we're going to send that to the client. So to sock, did I call it to sock or to socket? To socket. Print line. We'll print that string out, and then we'll flush, and we'll just do this forever. Alright, so our from keyboard is just a scanner created on system.in. We can't throw exceptions when that happens usually, so we don't have to put it in the try-catch block. We do have to import Java util scanner. Alright, so we've got from keyb. What doesn't it like there? I typed something wrong. Okay, here we go. All right, so there's going to be our main loop in our thread, right? Read from standard in, which is our keyboard, send to the client. So it's going to read from that scanner. It's going to send it to the to socket, and then flush it out. Okay, we need to know what to socket is, right? So what's to socket? It's a print writer. So let's put a print writer inside our class. And let's get this from the main program when it creates us. So before we go into this loop, we're going to construct our new thread. So what do we call this? KB to socket new thread equals new KB to socket. And when we construct, we're just going to pass in, let's just pass in that to socket object. Alright, so we need a constructor over here. And it gets an argument of type print writer. Alright, so we construct by passing a print writer to send to the client. So this is all happy now, right? We construct our thread. We pass it the to socket, which was the print writer we created. And over here we will save that in this local variable called to socket, right? And then we'll use that inside our while loop to talk to the client. We'll end our run method right here. And then the last thing we need to do is we need to start this thread. So how do we do that after we construct the thread? We just say kb2 socket dot start. So make a new socket and call the run method. Make a new thread and call the run method. And I got another typo somewhere. What am I doing here? Oh. It's Tuesday, man. I was up till 1 o'clock making videos. So this is a new thread dot start. Okay, so call the start method in our new thread object. All right. So that that should set us up, right, to do this. This is our main method, right? Before we get into this loop, we construct a thread, right? This new thread. We tell it what the print writer is, and then we let the thread start executing in its own process by calling the start method. It calls the run method, and it does this loop which reads from the keyboard and sends to the print writer. Okay, so let's see if this does anything close to reasonable. So our server is running. Our client is over here. We'll do our telnet connection. Here's client 1 message, here's client 2, here's client 3, right? And those all came in even though we didn't send any messages from the server yet, right? So here's S1, S2, S3, and those are all coming out. And I can start typing. This is a very long message, and while I'm typing, I can say, hey, the interrupting cow, and it pops out in the middle while I'm typing over here, right? So these are truly two independent processes now. The one that's reading from my keyboard over here and sending to the client, and the one that's reading from the client, right, and sending to standard out. And, you know, I'm in the middle of saying something, right? I can send something from the server and it pops out immediately on the client side. Okay, so that's a superset of what you need to do for your PA5, right? PA5 is much more controlled, right? We get one message, we send one message, but it doesn't matter, right? These things are set up as threads. They have their own independent existence. Okay, if I shut down the server, my client notices that that the connection it was sending to is no longer available. It shuts down and exits, and the thing that I was in the middle of typing now got passed to bash, right? And bash is going to pick that up as a bash command. So all this stuff interacts with Unix. All right. So any questions about this pair of classes here, right? What I've done here, basically taking this thing that used to send, receive, and now splitting it into two parallel processes, one that just sends and one that just receives, right? And you're doing something like this, probably very much like this, in your PA5. All right, so I'm going to throw out some forbidden knowledge now. This is something I used to teach in the beginning of this course, and it leads to really bad habits. And so we're far enough down that I'm going to mention this now, and hopefully it won't destroy everybody's habits. But when we're dealing with setters and getters in particular, right? It's really common. For example, here. I've got this KB2 socket, this thread that I was creating, and I wanted to pass it this thing called toSocket, right, which was a print writer. And over here, I wanted to save this thing that was passed in a local variable called toSocket, right? To me, toSocket is the most logical name for this variable, right? Because this is a thing that I use in order to send something to the socket. Okay, but when I wrote my constructor and I had an argument coming in, I used PW, right, for print writer, and then I said toSocket equals PW, right? And if I had simply said toSocket, and I change this to say toSocket equals toSocket, that's silliness, right? Because once I say my argument is called toSocket, well, this toSocket refers to this local argument. Has nothing to do with this toSocket. Okay, and this statement is a no-op. It's not going to set this variable equal to that one, because toSocket is a local variable. Okay, so what do we do? Well, sometimes you see people do things like this, right, where they call the argument underscore toSocket, and then they set toSocket equal to underscore toSocket. And that's not horrible. But it's a bit of a kludge. So here's what we can do. We can do what we had a moment ago, toSocket equals toSocket, but we need to specify which toSocket we mean. Okay? If we just say toSocket completely unadorned, then we mean, you know, whatever is most locally scoped and called toSocket. Okay, in this case it'll be this variable that's declared as an argument right here. But over here, we really want this toSocket to be this toSocket up here. In other words, the toSocket corresponding to whatever object we are in. Okay? And remember, there's this keyword, this, THIS, which always refers to the current object. So what we can do is we can say this dot toSocket equals toSocket. And this is saying, let's take the argument, which is a print writer, and let's copy the value to this variable up here. And you'll see this all over in code, especially in mutexers, things that are taking an argument and then setting a variable equal to its value. And this is a perfectly appropriate use of the keyword this. Okay. The reason I don't talk about this earlier anymore is because once people do this, they start going crazy. And they do things like this dot ss, this dot from keyboard, this dot sock, this dot from socket, this dot to socket, right? And if you're not doing that in a static class, it works perfectly well, but it's unnecessary, okay? If I'm sitting inside this class and I say to socket, right? Right? This does exactly the same thing as if I don't say this. Okay? So there's this notion of scoping in programming languages, right? When I say to socket, it's the compiler is going to look to see, is there a to socket declared somewhere inside this while loop? No. Is there a to socket declared somewhere inside this method? No. Is there a to socket declared somewhere above this method? Maybe, I don't know. Oh yeah, right here, there's a to socket. Okay, that's what this to socket refers to, is this one right here. When I say the word buffer, it's going to say, well, what buffer do I mean? Is there a buffer declared inside this while loop? Oh yeah, right here, that's the buffer I'm referring to. Okay, so if I had something like string buffer, right? And down here, I really wanted to load into that, string buffer at the top. I could do this dot buffer, and it would refer to this variable. Okay, but since I don't have that, right, I can just say buffer, and it's going to refer to whatever the closest scope is. In this case, this thing right here. And if I just say to socket, it's going to refer to this one. So you don't need to say this unless there's an ambiguity that you're trying to resolve. Okay, so don't start putting this on every single variable that you mention in your code. Okay, you can do it, but it's redundant and it's just kind of not cool. But in this one line right here, right, there's very clearly an ambiguity. To socket might mean the argument, to socket might mean the class variable. Okay, I say this dot to socket to say the class variable. So that's just a thing that you'll see a lot when you're looking at code, and that's all that's going on with that. It's a way to get to a class variable if otherwise your variable name would be ambiguous. All right, questions on any of that? All right, so let's talk about threading. Why do we want to have threading? We've seen one case here where we have something involving blocking reads, and we want to be able to do something even while something else is waiting for an event, right? And this is where threads come in to swing, right? We've got code that's waiting for a mouse click, but we don't want to just sit in a loop and say, did you click the mouse? Did you click the mouse? We want to go off and do other things. So we have a thread which is responsible for noticing when the mouse is clicked and then calling code appropriately, while we're simultaneously doing things like communicating with another player or whatever it is we're doing. Threads are useful when you want to run something in the background. For example, you're writing a browser, right? And you're loading a web page, okay? And while you're loading it, you're writing a local copy of everything that you're pulling into your cache. Okay, so you're creating files in a directory and you're updating an index of pages and stuff like that. You really don't want the user to have to sit there and stare at a broken screen while your code is doing this cache update. You'd like to do it in the background. So you could create a separate thread which goes off and, you know, indexes the pages that you just pulled down and updates the cache directory and updates those indexes and so on, while the user is continuing happily away with their online experience, right? Or you're doing a text editor and every 5 minutes you want to save the current file into a temporary area so you can recover if things crash. So every 5 minutes you're typing and all of a sudden your keyboard freezes while the program starts writing a backup copy, right? That's really annoying. So what you might do is when your 5 minutes is up, create a new thread that takes a snapshot of your current file and writes it into a directory. And while that's happening, the user is continuing to type. They're continuing to do whatever it is they're doing. All right. So we like creating threads when we want to have, you know, more than one thing happening at once. Things get interesting if potentially these two things that are happening at once might interact with each other, especially if they might interact in a way that we don't anticipate. So let's take the example of writing a text processor. So you're typing in some text, and at some point, you know, 5 minutes, you create a new thread. I'll call it my save thread, which is supposed to take all of this and write it out to your disk. Right? This is useful because while this is happening, right, and this might be a slow process if it's a big file and a slow disk, while this is happening, the user can continue to type. Well, you know, what if they're typing a document A, B, C, D, E, F, G, and 5 minutes hits and you start writing this out to disk. So you write out the A, and you write out the B, and you write out the C, and now the person does the following. They decide they're going to swap paragraphs A and D. So they write paragraph D up here and paragraph A down here. And now your thread, which is doing its own thing on its own timetable, continues looking at your file and says, okay, I have to write out paragraph A, and I have to write out paragraph E. And now the person decides to move paragraph A further down the document, and so they swap it with paragraph G. And now your thread, you know, gets more of the CPU time, and it writes out paragraph F, and it writes out paragraph A. And at this point, something happens, and the user decides, okay, I'm going to go back and get the last saved version of my file. So they exit and they load in their file, and this is what their file looks like. Okay, and that's not their code, and they've lost information, right? They lost paragraph D and they lost paragraph G, and they're very upset. Okay, the reason this happened is because you had two things accessing this data, and in particular you had something modifying it while something else was trying to read it. Okay, this is a classic problem. And you might write code to do this, you know, to after 5 minutes make a thread that copies from here to the disk, and you test it, you know, 5 or 6 times and it works perfectly. And then you deploy it and there's a million people using this code, writing 12 backups an hour for a few months. This is going to happen, right? And you're going to start getting reports from users saying this software is terrible, you know, this corrupts my file all the time, don't use this. And you tested it and it worked fine, you know, but you didn't test it, you know, millions of times. And threaded code, multi-processing code is notorious for these kinds of issues. Okay. So let me show you an example that we'll build on tomorrow. Let's look at a bank. Okay, so here's a bank and here's an ATM. And here's your job. And your job is you know, it's payday, and they're going to pay you your weekly salary. Okay, so they're going to deposit $100 because you're a teacher or something. No, they're going to deposit $100 into the bank. Okay. And I'm over here at an ATM, and I want to make a withdrawal. I want to get $20 cash. Okay, and let's suppose my initial balance is $250. Okay, if my employer deposits $100, that's $350. If I withdraw 20, I should end up with $330 in my account, $20 in my pocket. If I withdraw my $20 first, I'll have $230, and then when my employer deposits $100 on top of $230, I'll have $330 in the bank, $20 in my pocket. Okay, but here's what can happen. Because this deposit and this withdrawal can be happening simultaneously, if the bank does not write its code properly, here's what can happen. So how do you do the deposit code? What's the deposit method look like? Bal equals balance. Bal equals balance plus 100. Balance equals bal. Okay, where this is just a temporary integer. So read the balance, that's 250, add 100, bal is 350, set balance equal to 350. And then on the withdrawal, it's going to say integer bal equals balance. And then subtract 20 from that, and then set my balance equal to that integer. Perfectly reasonable, right? Very, very straightforward code. But if both of these processes are running at the same time, here's what can happen. Let's say that this starts to execute first. Okay. It says integer bal equals balance. So bal is equal to 250. And then it says add 100 to that. So it says bal equals 350. Before it gets to the third step, this thread starts to execute, and it says set bal equal to your balance. So bal equals 250. And then it says subtract 20 from that. So now my balance is equal to 230. And now this thread gets a slice of CPU time, and it says, okay, set the balance equal to bal. Okay, well, bal is 350, so the balance should now be $350. And this thread is finished. Now this thread comes back and it says, okay, set the balance equal to bal. What's bal? It's 230. Okay, set the balance to 230. This thread finishes execution, and both transactions are done. I've got $20 in my pocket. I've only got $230 in the bank. My deposit disappeared. This is really easy to have happen if you don't manage multiple processes correctly. And what happened here, right? This thing started to go through what's called a read, modify, write. RMW. It read the balance and made a change to it, and it wrote it back out. But this thing also started to do a read, modify, write. It did the read, it did the modify, but before it did the write, this thing had written its balance. But then when this thing wrote its balance, right, it undid the effect of this thread's read, modify, write. And any time that you have this kind of read something, make a change, write it back, if that can be interrupted, you have the potential for this kind of data corruption. So what we'd like to do is make this read, modify, write what we call atomic. Okay, so what's an atom? It's a thing that was considered to be indivisible. right? You take a stone and you grind it up into powder, and you grind that into sand, and you grind that into dust, and how far can you grind it? And the Greeks, had this idea of a fundamental limit to how much you could grind something, okay? And that was the atomic element. So an atomic operation is an operation that cannot be split into pieces. And normally two threads, we were running parallel threads yesterday that were counting, right? And while we were halfway through a for loop for one thread, the next thread could kick in, get some time, and start executing. So that for loop was not atomic. It could be interrupted. If the read modify write that's updating this is allowed to be interrupted, we can have this data corruption. Now, if this was an atomic unit, as soon as this started to take place, this thread could not get any time until the balance had been updated, which would have left this at 350. And then we could have started this operation, taken away 20, we would have had our 330. And if this thread had started first, this would not be able to start until this finished because this was an atomic unit. So one of the keys to managing processes and avoiding this kind of corruption is being able to atomize operations. Okay, so we'll look a little bit at that tomorrow. We'll talk a little bit about the idea of flags and mutexes and things like that. We won't go into a lot of detail, but I'll also go through a Java example showing this kind of data corruption coming from multiple threads. All right, so we'll continue with that tomorrow. All right, thanks. Have a good day.